Okay. And here we go. Okay, George Steed, Master Watershed Steward.
Yes. So I have been involved in with Carol Armstrong over I guess since January. So I'm relatively new at this, and it's been real exciting and a lot of fun, and I feel fortunate to be participating in this. So primarily, it's sort of evolved that I have become responsible for SL. Mike had referenced these two stations, SL 135 and 138. Carol's primarily now handling 138. I'm handling 135. What we are trying to do here, and we'd like feedback on, is we're looking at the variability of the total suspended sediments and chloride in the sediment loads for each site separately. And then also the second issue that we're struggling with is short-term peaks in conductivity at SL 135 at the Montgomery School site in Chester Springs. This just gives you an idea of what each watershed looks like in terms of the land use. The Montgomery School site, SL 135, has a bit more development. Primarily, the differences are more development and less deciduous forest. You can see, as consistent with what Mike indicated, farther downstream, you see more deciduous forest and less development and a little less ag use. So our first question is, what's the variability of TSS and chloride in sediment loads for each site separately? This just gives you can see the rating curves here that we have for depth to discharge for each site, as well as the rating curves for the turbidity to TSS and conductivity to chloride. So we have some data. What we want to understand really is how much variability there is in these TSS and chloride at each site. And what we would like to do is calculate TSS and chloride loads for a certain number of storm events for 2018 and 2019. And then, if possible, I guess one of the things that we're curious about is that, can we use, will we be able to compare that to the data in the paper that Dave referenced earlier, the Sloto paper, which studies the TSS and chloride loads in Chester County. So I guess one of our questions is, should we select storm events based on a specific depth increase? In other words, define storms as an increase in depth over a specified millimeters or percentage increase, or would a better criteria be holding constant change in depth or should we select storms over a certain precip amount regardless of the stream depth increase? Like, what's the criteria we should use in selecting the storm events? And I mean, I guess that would be the first question I would throw out as to, anybody have any feedback on that? How we select our storm events?
I have a correlation I'll show you.
Okay.
The two key variables are the rising slope of a runoff curve and the quantity of water. The quantity of water up until the point where rainfall ceases after you cross the peak. And if you multiply those two together and plot that versus sediment per acre generated, then you're able to characterize the number of storm events in a year, for example, and what percentage fall into those categories, and give you a sense of what's going to happen. So in an environment where you have more rain, more frequently the soil is moist, and you're going to get more runoff, then you're naturally going to have much higher runoff curves and a shorter peak, and you're going to get more sediment generation.
Mm-hmm.
Chloride, I don't know about.
Yeah.
But for sure in the TSS.
Okay.
Well, one thing, to comment on the chloride, you see peaks in conductivity with here at Marsh Creek. Whenever there's a storm event, we see a dip in conductivity.
Mm-hmm.
Except, in fact, in my file, show one example where we don't. But
Yeah.
most of the time, it's a dip. We think it's simply the marsh doing its thing, filtering, and a storm event, it just sort of flushes the system out.
Yeah.
And you see a decrease in conductivity.
Mm-hmm. Yeah. Well, in the next problem, we'll get to some of the problems we've been seeing with conductivity. But, okay, so I'll have to get to you to discuss that a little bit further because I don't fully understand that, but it sounds very interesting. Okay, yeah, great. So I don't know if anybody else has any other feedback or comments on things that we might want to be looking at or
what would your
other
objective
criteria
be in terms of quantifying the sediment in a year or per rain event? You know, what, as opposed to TSS, you want to quantify the amount of sediment that's being deposited?
Well, that's partly, from at least from my standpoint, being new to this, that's like maybe part of what I'm interested in knowing. I mean, I don't know. Are we interested in looking at quantifying it for the year, or are we looking at?
So sort of like what's more important, concentration or total demand, total load?
Yeah.
So, David, have you put stuff, like continuous samplers out with these mayflies yet?
Continuous sampler meaning.
ESCO, I can't remember the name.
Oh, well, no, I don't think we have any ISCOs directly associated with any of these stations.
That would answer your question. See, automated samplers like $20,000 to get done.
Yeah.
But you have them. If you had that next to the sensor, you could see if that sediment to turbidity ratio, you collect 24 samples or whatever during a storm event.
I mean,
it's a good question.
George, you're sort of just still kind of questioning, like, really, well, what are we doing here, and what information is really most necessary to kind of give us some insights on what's happening in the watershed, how the watershed is changing, and how can that information help with insights on doing stuff in the future to, help with that state of affairs. Right?
Yes, I think that's a fair characterization. Yeah. Yeah. Well, and I think that we will be collaborating more closely with Mike going forward.
Yeah. Yates, the Watt team, and Bullard, and you and Carol, I think that would be a good little working group. But I think what you were mentioning about comparing to the Sloto paper, I think there's some, that was done a decade ago, and that has specific storms in it.
Mm-hmm.
That has sediment quantities, sediment loads for specific storms, which have a certain amount of precipitation, occur at a certain time of year, have a certain discharge associated with them. So it seems like, where we see a year like this past one, where, Pickering, it was practically running high and dirty, like, on most days, right? Maybe that's a little bit of an exaggeration, but it was super high, and a lot of storms that were, kind of out of character for that general system. So, is that related? There's the climate change thing with the increased intensity of storms and amount of rainfall. But in terms of comparing this year, do you compare this year or this past year, 2018, to any of those estimates they developed in that paper a decade ago, and what does that tell us? And there's a lot of questions within that, but certainly, just a comparison between years seems like it could be at least informative about like just what this excessive rainfall is doing to these systems on a broader perspective. You know, it seems to me at least. You know, because obviously there was I don't know. I mean, at least, I would guess at least double, triple, more than that, potentially, sediment transported last year than the year studied in that paper.
And that actually, as a finding, would be tremendously valuable all in itself, that you can correlate a 50% increase in stormwater with a 200% increase in sediment. That would be really interesting.
And, you know, and luckily, those two Pickering main stem stations actually have fairly good turbidity data.
Yeah.
Relatively
Not
speaking.
luckily at all. Carol and George have done a tremendous job. Very grateful.
Yeah. Well, is it a fair comparison to compare that data to the data in the Sloto paper, which is for different streams?
Now, the Pickering is in that. There is.
Was there a Pickering slide in there? I know French was in there. I didn't.
Maybe not.
I don't remember Pickering.
I think French is in there. Yeah.
So the important thing would be to standardize that.
Yeah. Okay. Yeah.
You know what I mean?
Okay.
Based on like watershed size or whatever,
Mhm.
I guess. Maybe they can.
All soils. I think it's going to.
Have some way to standardize that and do a comparison because it's regional and that's what you're banking on.
Okay. All right.
Right?
Okay. Good. Well, thank you. That's helpful. Maybe we can regroup on some of those questions. I know I have to move on. And then, you know, the other issue that we have here is what's causing short-term peaks in conductivity at base load depth to Chester Springs or the Montgomery schools. Sorry, that's 135. And here you can see it's like just like out of nowhere at base flow, you can see the stars indicate where the jumps in conductivity are occurring for, you know, and so. Pardon me?
Flushing or something?
Yeah, well, that's what we can't quite figure out. Carol and I actually, you know, the peaks seem to occur during the week. I don't know, weekends. We can't really find a discernible pattern.
10 a.m.
Yeah.
No, they're at 10 a.m.
But well, I know that often, yeah, but not always though.
Go back to that.
What's that?
Go back, yeah. There's some point source, somebody dumping.
Well, yes.
Pretty
Well,
regular.
there are two outflows from the development that flow under Route 113, and you know, but the peaks will sometimes occur like, you know, it's like the one jump we noted goes from 334 to 729 microsiemens per centimeter, or microsiemens in 5 minutes. And then the peak duration appears to last 10 to 30 minutes. Carol and I got there. Unfortunately, you know, we took out the SD card, plugged it into the laptop, and saw we were right at a peak at that time. So we jumped in the stream and went upstream for a couple hours trying to find the points with no luck. I mean, it was consistent all the way upstream.
So I camped out there a couple days on the bridge above it.
Yeah.
Because the transmission was intermittent, but I caught it transmitting a peak, and there was nothing in the 3%. So we know where the problem's at. So somebody has to do something about it.
You know where they
do now?
Well,
Name.
Yeah.
So can we talk about this afterwards?
Yeah.
Well, no,
Seriously,
Colin.
definitely a case that's voiced by their guitar kind of thing. So there may have been some recent construction that maybe something got connected to the wrong thing.
Okay.
Can we talk about that first? I thought you guys would have taken care of it.
Yeah.
Was that something you should report to the DEP?
Well.
Huh? No?
Anyway, so okay, we'll discuss that in more detail later. So. Okay. Any other questions or thoughts, comments?
These are great questions. So I think the soils are going to have a lot to do with it. I noticed that your rating curve for turbidity versus TSS was more like 3-to-1 versus
high.
Yeah. So I would be very interested to see what's going on with that. It's pretty easy to map the soils above it and see if there's a difference between perhaps multiple sites that Florida did and then these two sites. I think that's an interesting
I think
question.
their ranges were between 1.6 to 1 and 1.96 to 1, so it was a little under 2.
And
There's also the sensor component of that as well.
One was
We're
high.
talking about that.
we don't know if the sensors are actually correlating currently with, And I have, I'll keep looking for more turbidity sensors.
But the other point you were making there, Mike, was that the possibility of just different assemblage of particles that are contributing.
It's always going to be different. And it's going to be sorting itself, and it's just stuff gets eroded and then gets fed load and then picked up again. The variability of what particle size we be passing with sensor is beyond ability to predict or model. I think you just have to collect samples every month.
Okay.
Get a range.
Okay. Yeah, but Mike, on the conductivity issue, you're pretty confident that your understanding of what's causing that would be the same as what we're seeing now? I mean, that continues?
Yeah, I dug in on that pretty hard.
Okay.
And I thought, just because I assumed you guys were taking care of it. And because the station is not transmitting anymore. I haven't been able to see those spikes.
Well, that.
Yeah, it is transmitting, but it's transmitting. It's intermittent. It's yeah. But we.
You're looking at me and saying taking care of. Are you meaning the station or the issue on?
Well, you're the guys that brought it to my attention.
Okay.
Well, I just brought it.
And I reported to everybody in the loop that I was camped out above it and that I'm taking samples and did not see anything.
Yeah.
At the same time, the spike was.
Well, yeah.
And so I handed it back to you guys.
Yeah, we didn't see anything. We went all the way upstream, up to the bridge, and the conductivity was consistent. We sampled every 40 to 80 feet. And then going back and looking at the data, there was a spike occurred actually while we were sampling upstream, which would indicate that the source is somewhere between where we were upstream and the sensor.
Yes.
So.
Yes.
Wait, so are you saying
That's
are you saying that it was an issue with the sensor itself?
No. I'm saying that there's been some new constructions there at Montgomery School, and I suspect someone took a water softener or something. And you could watch the vehicles come in.
Oh, you're saying,
The same
right.
guy who installed the sensor. So if everybody would just let David, doesn't David understand?
He's not there anymore.
No.
He's not.
Yeah, he has.
And that's where it's sort of an awkward thing because George and Carol are accessing the site because they have a relationship with the school. But there's no one at the school anymore who's really.
Right.
It's a teeny amount of something, and it's almost definitely it looks like a kitchen or something in a new building. So we'll figure out. I would talk to David again because he's still in the loop.
I mean, it's probably Klein and Carol and George that are going to be doing that. I don't think that's Stroud. Stroud is not advocacy.
Okay.
Yeah.
Okay. Very good. Very good. Thanks.
I mean, that seems like something that Carol and David could work out, and you, George.
Okay. Yeah. I mean, David, I think, has been aware of it because I think he chimed in on one of our email exchanges, but it didn't seem like he was on top of it. So I don't know. Maybe I should use those words, but he was not jumping in.
Yeah. Someone has to take this to this administration school and get it corrected.
Yeah. Well.